All righty, welcome everybody. Welcome to our Morrison Planetarium stream of our 4:30 show on this wonderful Wednesday afternoon. I just want to introduce myself to everybody. My name is Christian. I'm going to be your planetarium presenter, and today we are in for a special treat. We're going to be pretty much flying through our solar system and exploring all the different planets in our solar system. We're going to get an up-close personal look. But before we do that, I want to start off pretty close to home at this really funny looking object that we're looking at right now. Now, a lot of people tend to think that the object that we're looking at is a satellite, but it's not a satellite necessarily. What we're looking at, folks, is something called the International Space Station. We also like to call this the ISS for short. And in fact, let's start getting a better look at it. I want to swing us around so we get a better look from the front because it looks like we're on the backside of the ISS right now. But as we're rotating around, you're going to see the Earth just down below. I believe we just passed New Zealand not too long ago. We might still be able to see New Zealand. Yes, there it is in the background right there. But as we swing around to the front side of the ISS, it doesn't really look like a normal satellite. Again, as I mentioned, this is a research facility that's orbiting around planet Earth, which is pretty interesting to say because there's a lot of different types of research facilities around planet Earth, but not one that orbits around it. So essentially, the International Space Station is a collaboration between many nations across planet Earth. So we have the assistance of the Space Agency from Russia. We have NASA from the United States. We have the European Space Agency. We also have the Space Agency from Japan. And all these folks pretty much want to figure out what happens to things in space. So they conduct all sorts of science experiments up here on the International Space Station. For example, how do plants grow in a low gravitational environment out here when you're far away from the planet? How does water behave out in space? Does fire behave the same way when you're close to our planet with gravity? Well, these are all the different types of questions that scientists wanted to figure out. So these are the types of science experiments that have been conducted up here. And what's really interesting is that the International Space Station first began in 1998 because NASA sent the first module up here. And then since then, we've added 12 other modules to create the International Space Station of what we're looking at right now. But from here, it looks like the International Space Station is enormous, especially on our web screens. But it's only about the size of a football field, an American football field, so not too big. That's about the size of the California Academy of Sciences, the museum in which I'm broadcasting from. But what's also really amazing is that this thing's also not too far away from planet Earth. We can see the Earth just below us, but the International Space Station only orbits 225 miles above the surface of planet Earth, so not too far away. And in order for it to orbit, it needs to go at a whopping speed of 17,000 miles per hour. That's just fast enough so that you don't crash into our planet Earth. You're pretty much free falling, constantly falling around our planet. We also like to call this orbiting around the planet. But not only that, folks, because this International Space Station is traveling so fast, this thing goes around the Earth once every 90 minutes. Woo, that's incredibly fast. Not only that, it also experiences 16 sunrises and 16 sunsets a day. That's very romantic. And just to let you know, folks, this is as far as we put humans into space nowadays, only 225 miles above the surface of the Earth, because traveling into space gets quite expensive. You got to get yourself a rocket ship. And then you got to get rocket fuel for that rocket ship. And you're going to need a whole heap more rocket fuel to get that rocket and the rocket fuel off of the planet. Then not only that, you're going to need to bring a crew, all the life support systems you need while you're in space, and all the food, water, and all the air you're going to be breathing up here as well. So the bill starts to get quite costly quite rapidly. But it looks like we've explored the International Space Station for a good amount. So we're going to start to slowly leave it behind. And as we do so, we're going to see it slowly disappear compared to the Pacific Ocean of our planet Earth. And as we lose sight of the ISS, we have a nice little orange line, which is going to show the position of it. And now we're zooming so far away, now we're able to look at our planet as a whole. There we go. And by the way, folks, I'm not sure if I mentioned this earlier, but the program that we're using here is the same program that we use inside our Morrison Planetarium to do our 4:30 Planetarium show. This program is called Open Space. And now what's amazing about Open Space is that this is an open source program, which means anybody can go online, openspaceproject.com, planetarium.com, and you can download this program on your computer. Just to let you know, Open Space is a beta program, which means it's not completely finished. There might be a few bugs and glitches that we might encounter, but that's okay. I'll let you know if we encounter any of them. But again, you can download this program at home, openspaceproject.com. So very fun to fly through the universe. So, and one thing before we leave our planet Earth, I do just want to stress pretty much all the colors that we see on planet Earth. So when we look down on our planet, you notice that there's a whole heap of different types of colors that we notice. For example, we can see the whites of the clouds. We're hovering just above our planets. These clouds are filled with water. And then also as we get closer, we can also start to see the ocean down below, all the blues. So our world is covered in more than 75% of oceans of water. And then, of course, when we look towards the land, we can start to see all the browns from the rocky terrains and also all the greens from the tropical regions where lots of plants and life forms live, like us humans. Now, I just want to stress the shape of it, or the colors that we're seeing on planet Earth, because as we start to explore our solar system, you're going to start to notice that the planets in our solar system don't look anything like planet Earth. In fact, when we fly over to the nighttime, we can start to see all the city lights pop up in the dark. So we can see all of Europe. We can see all the extensive urbanization on the Nile. So lots and lots of city lights right on the river. But now we're going to start to slowly pull away, folks, because now we're going to be heading over to our nearest natural neighbor to us in space, the moon. Now, for me, I personally love the moon. It just has so much significance for us humans here on Earth. Now, we humans have traveled to the moon before, but this was quite a while ago. This was between 1969 and 1972. Excuse me. Sorry about that. But again, we humans have been to the moon before, and this was thanks to NASA's 6 Apollo missions that sent humans up here. Brought 12 incredibly lucky guys to walk on the surface of the moon, conduct science, and even got to play golf here. And as we get closer to the moon, you're going to start to notice all the craters that are littered on the moon. You also start to see all this dark gray stuff as well. But before we start to get into the texture of our moon, I do want to stress or give a quick shout out to an amazing person who helped get us humans onto the moon. I got to give a special thank you to Margaret Hamilton, who was the lead software engineer who programmed the Apollo guidance software and anticipated potential scenarios that might have led to pretty much, if there was any landing obstacles or situations, she helped program it in case any scenarios like that occurred. And her team also was able to continue the landing, even though there was a hazard that did happen as the Apollo mission was landing on the moon. So we got to give a big thanks to Margaret Hamilton for computing that program, that software. So big shout out to them. Amazing work. But again, folks, the last time we sent humans to the moon was a little over 50 years ago. So quite a while, and we sent them in pretty much an aluminum tin can in a sorts, at least our spacecrafts at the time. And they were also able to land on the moon and then return back softly to Earth. And pretty much, again, thanks to Margaret Hamilton, using that computer guidance software with only 72 kilobytes of working memory. That's less memory than what's in your smartwatch right now. So they were able to get all the way to the moon and back on a very small amount of memory for that program. So very cool stuff. But we humans are planning to send humans back to the moon again, not too far away, in a new NASA space mission, which is called Artemis. So Artemis should be launching in the next year or two. Keep your ears out for any news about it. But essentially, Artemis is going to be sending the first woman to the moon and also the first person of color to the moon. And not only that, one of the coolest things by far is that Artemis space mission is going to be setting up the first lunar base. So pretty much NASA's main goal is to send humans to Mars before we send humans all the way deep into our solar system. Because if you want to travel from Earth to Mars, it's going to be anywhere from 6 to 8 months. You have to wait a full year for Mars and Earth to get close again, and then another 6 to 8 months to return trip. So that's a 2-year voyage before we send humans all the way down there. We need to figure out how exactly we're going to live on another celestial body out here in space. So Artemis is going to be setting up the first lunar base. Very exciting. And also they're going to be having its own orbiter, just like how we saw the International Space Station orbiting around the Earth. They're going to have one called Lunar Gateway, another space station that's going to be orbiting around the moon. So pretty much in case if they needed to head it out or leave the moon, they can use their spacecraft, get out into orbit around the moon, and then land at Lunar Gateway. So lots of cool stuff happening with Artemis coming in the next couple of years. Hopefully everything goes according to plan, though. So very exciting stuff. But let's get into a little bit about the moon, because I love this place personally. One of the coolest things about the moon, for me at least, folks, is that this is the very few experiences that's shared throughout humankind. Now, for the most part, every human has seen or experienced the moon in their lifetime, which is pretty wild to say, because we don't have that much in common with a person 60 years ago, let alone 600 years ago, or even 6,000 years ago. But the moon ties us all together. It inspires much of human histories like legends, mythology, romance, and movies, and even cartoons. In fact, this is one of the reasons why there's a whole misconception of why the moon is made out of cheese, something that was created by early Hollywood and later on perpetuated by cartoons. But I can let you folks know for a fact the moon is not made out of cheese. It's actually very, very similar to the Earth's composition. So the same rocks that you find on Earth are pretty much the same rocks you're going to find here on the moon. And also want to show you all something. One of my favorite things. So here on Earth, when we look up at the night sky, it almost feels like we can reach up and touch the moon, but the moon is really, really far away. It's about 225,000 miles away from the Earth. Whew, 225,000, that's 250,000 miles. If you're on a rocket ship, it's going to take you over 3 days to travel that distance. But let's say if you got in your car and you wanted to drive to the moon from Earth going 80 miles per hour, it's going to take you about 4 months to travel to the moon. So quite a far distance to travel. Also, I want to show y'all what this dark gray stuff is that we see up on the moon. Now, a lot of people can see it here on Earth, and they're not exactly sure what this dark gray stuff is. This dark gray stuff is called the Maria, which in Latin translates to the seas and oceans. And when the first earlier astronomers looked up at the moon with their rudimentary telescopes, they thought these dark gray stuff were oceans. So they thought there were oceans on the moon. So that's why they named it the Maria, which again translates to seas and oceans. But we now know for a fact that there are not oceans or liquid water on the moon. We've landed here. We've gotten closer looks. Instead of these dark gray things are the result of giant impactors, asteroids that came and smashed into the moon so hard that it pretty much broke the crust of the moon. And back then, the moon still had lava, hot material inside, and that lava came up, filled in the lowland areas. And the reason why it's dark gray is because that lava was rich in iron. So a lot of iron deposits, which gives it that dark gray colorization that we see. But looks like we got a good look at the moon. So let's head on out and let's take a look at all the planets in our solar system. And as we start to zoom out, I'm going to be adding some planet trails so we can figure out where everything is in space, because as we travel far out into space, we start to lose the objects because space is so immense. So let's zoom on out, folks. So now we can see the Earth right in the middle, and then we're looking at the moon, the orbit of the moon. And now we can see the nearest star to us, the sun, right in the middle of our solar system. Now, just to let you know, the sun is by far the biggest thing in our solar system. It takes up about 99% of all the material in our solar system. That remaining 1%, that's all the planets, the asteroids that we have at least discovered in our solar system. So the sun, by far the biggest thing, no comparison. And also, the moon or the sun is incredibly far away from us. It's about 93 million miles away from Earth. 93 million miles away. Whew, that's incredibly far. If we were traveling at the speed of light, it would only take about 8.5 minutes to go from the sun to the Earth. So really fast way to travel out in space, traveling at the speed of light. But let's get a little bit closer. I just want to name the planets in our solar system as we zoom on out. So, of course, we have the sun right in the middle. The closest planet to the sun, we have Mercury. And then beyond Mercury, we have Venus. And of course, we have Earth, that's us, the third rock from the sun. And then the fourth, we have Mars. These are all the rocky terrestrial planets. These are places we can actually land a spacecraft on. And then beyond the orbit of Mars, we also have our main asteroid belts. And this is what the asteroid belt would look like if I highlight all of them. Now, one of my favorite things about the asteroid belt that I just recently learned is that it was first discovered in the 1800s by a European, pretty much astronomer association. They called themselves the Celestial Police because they were trying to find a missing planet, which at the time was Ceres. We now have demoted Ceres into a dwarf planet. But very fun fact, the Celestial Police have discovered the asteroid belt in the 1800s. So really fun fact. Oh, yes. We'll take a look at Saturn in just a little bit. I see your message right there, your comment. But beyond the orbit of the asteroid belt, of course, we have the really big planets. We have the Jovians. We've got Jupiter, Saturn, and then we have the icy giants. We have Uranus and Neptune. So these are the objects in our solar system. And real quick, I also want to add Pluto so we can show folks the orbit of Pluto, which just came on screen. So that's the orbit of Pluto. And just to let you know, Pluto is now considered a dwarf planet because we found so many objects out here in the outer part of our solar system beyond the orbit of Neptune, which is called the Kuiper Belt. And if you don't know what the Kuiper Belt is, let me show you. And this is the Kuiper Belt, folks. And unfortunately, it looks like I'm flying out of control. There we go. So yeah, again, Pluto in the past used to be considered a planet. But we got really good about learning the outer part of our solar system in 2006. And we found more than 400 objects same size as Pluto. Some of them were way bigger than Pluto, so we couldn't call all this stuff planets. So all the astronomers across planet Earth came together, had a great big meeting, had to figure out exactly what you need to be considered a planet. And one of the criteria is that you need to be so big and so massive that you push all the other objects in your orbital path out of the way. Unfortunately for Pluto, it doesn't clear that definition, and it actually orbits its own moon. So this is one of the reasons why Pluto got kicked out of the Planet Club and now considered a dwarf planet. But let me put the Kuiper Belt away because that's just a whole lot to look at. And I did see a comment that somebody wanted to take a look at Saturn up close and personal. So now we're going to be flying over to Saturn. And by the way, folks, you're more than welcome to type in the comment section what solar system object that you want to take a closer look at. The show that we're doing today is much more interactive. So now we're flying towards towards Saturn. And before we do that, I do want to turn off the asteroid belts because that is a whole lot of data points. We don't want to overwhelm our program. All right, now we are approaching Saturn. There we go. So again, we are now taking a closer look at Saturn. It looks like I'm just down below. Let me orient ourselves correctly. There we go. So Saturn is the second largest planet in our solar system, just right behind Pluto. And this thing is enormous. And this is also one of the Jovian planets, a gas giant. So this place is mostly made up of hydrogen and helium. If you're trying to land a spacecraft onto Saturn, well, you're not going to land on anything solid. Instead, you're going to fall through the clouds of Saturn until you go so deep towards the core of this planet that the pressure becomes so immense. It's kind of like when you dive into a very deep, deep pool, the pressure under all that water has a lot of weight. So the same thing happens here on Saturn. As you get closer towards the center of the planet, the pressure gets super immense, and eventually your spacecraft would be crushed. So word of advice, don't fly towards the center of Saturn or any Jovian planet. You will be crushed. And of course, one of the most recognizable things about Saturn is its gorgeous ring system that we can see here, very easily viewable from Earth. If you have a good sized telescope, you're able to see Saturn up in the night sky, usually around fall, about this time of the year. You can see Jupiter and Saturn in the evening sky. But a lot of people tend to think that the ring system that we're looking at is solid. It almost looks like a blade of a sense, but it's not solid at all. In fact, the ring system is made up of rocks and ice. The reason why we're able to see the ring system so vibrantly or so easily here on Earth is because a lot of the ring system is made of ice, so that ice is reflective, which reflects a lot of sunlight, which we're able to capture through our telescopes here on Earth. And a lot of people are not too sure, how did this ring system come to be? Well, in order to get a ring system, you need to be a very massive planet. In fact, all the Jovian planets, Jupiter, Saturn, and the icy giants Uranus and Neptune, they all have ring systems, but Saturn is the most prominent of them all. Now, most of these planets are enormous and have really strong gravitational pulls, so they tend to have a lot of moons. For example, Saturn has 82 moons and Jupiter has 80 moons. Now, most of these moons are captured asteroids that happen to be asteroids through the asteroid belt that got launched out, and they happen to get pulled in by one of these Jovian planets. And as these asteroids or captured moons get closer to these enormous planets, they will eventually get ripped apart by the immense gravity of these really massive planets. So as the moon gets closer to Saturn, it'll get ripped up bit by bit, shredded, and over millions of years, it'll create this beautiful ring system that we're seeing here. Now, a lot of the ice that we're seeing here comes from a nearby moon that has ice geysers that shoots out, and those geysers do interact a little bit with the ring systems that we're seeing on Saturn. And just to let you know, the ring systems on Saturn aren't going to stay here forever. They will eventually disappear as the inner parts of the rings are slowly falling towards the planet. So they'll start to fall towards Saturn and eventually fall through the clouds and go towards the center. And before we leave Saturn, and again, feel free to put in the comments whatever place you want to head to in our solar system. But I do want to show you one phenomenon that happens on Saturn. So here on Earth, when we see storms like a hurricane of sort, we tend to see a circle. But it doesn't really happen on Saturn, because at the North Pole of Saturn, we have this storm that has 6 sides, a hexagon. So I don't know if you can see the outline, but we can see 6 sides to the storm. Scientists aren't exactly sure why this phenomenon is happening. This is one of the things that scientists are still researching today to figure out how exactly does a storm create 6 sides. That's something we've never seen or heard of. Our best guess at the moment is that it has to deal with the polar winds. As the winds come down from the poles of Saturn, it pulls on certain regions, which creates this defined storm. But again, that's our best guess. We're not exactly sure how this came to be. So one of the many cool things that science is still studying to figure out. All righty. But let's zoom out of Saturn. And we still have a good amount of time to take a look at other planets in our solar system. If anyone else wants to head somewhere. If not, I'll head over to Mars, because Mars has some really amazing stuff. Alrighty, we're going to head on over to Mars. And again, if you want to go somewhere specific, just put it down in the chat. We'll head on over. So we're making our way to the farthest rocky planet in our solar system, Mars, just next over to us. It takes about 6 to 8 months to travel all the way out here from Earth. Now, you'll tend to see a lot of news about Mars on either on NASA or in space. A lot of space news tends to revolve around Mars, and it's because Mars is somewhat similar to Earth. This is somewhere that humans could possibly live one day, although it's not as nice as Earth, because here on Mars, it's incredibly cold. A lot of people tend to think Mars is a very hot planet because it's red, but that's a common misconception about this planet. It's not hot. It's actually quite cold. So an average day on Mars on a warm day is about 40 degrees Fahrenheit. And on a very cold day, it's about negative 180 degrees. So these are temperatures that we have here on Earth, usually at the north and south pole of our planet. So we humans can live out here, but it wouldn't be the nicest. Also, Mars is slightly smaller than Earth, and it also doesn't really have much of an atmosphere. It has a very weak atmosphere. And as we're flying around Mars, you're going to notice that there are certain data sets that are still loading in. There we go. But one of my favorite things about Mars is that it has the largest geological features that we have here in the solar system. So right now we're hovering above the largest volcano in our solar system. This is called Olympus Mons. In fact, let me turn off the nighttime so we can get a better look at it. There we go. So What I just pulled up right now is some high definition images. It kind of the data set kind of looks scattered. This is because the orbiter that's flying around Mars pretty much got sections of Mars. So we have some high definition res strips, but we can see Olympus Mons right below us. Now this thing is incredibly large, folks. Biggest volcano in the solar system. So what's really fascinating is that this is a shield volcano, and if you were to start at the very bottom of Olympus Mons and you'd hike all the way to the very peak, you can technically hike into outer space. This thing extends above the atmosphere of Mars. So that is a very, very long hike. And just to give you an idea of how large it is, the entire volcano takes up about the same size as the state of Arizona here in the United States. So quite enormous. But just to let you know, this volcano is now dormant, no longer active, hasn't been active for a few million years. But not only that, at the very top, you can also see a caldera. This is pretty much the mouth of the volcano that collapsed after the last eruption. And just to give you some size, this whole caldera is 50 miles across. So quite large indeed. And in terms of its vertical height, this is actually 3 times taller than Mount Everest here on Earth. So Olympus Mons, by far the biggest volcano, biggest mountain out here in the solar system. But also, not only does Mars have the largest volcano, it also has the largest canyon in the solar system as well. In fact, just so we can look at it a little bit better, let me turn off our high res so you can see it. But what we're looking at is Valles Marineris, again, largest canyon in the solar system. Now, to give you some perspective, if you started from the left side of Valles Marineris and you traveled all the way to the right, this is about the same size as traveling from San Francisco all the way to New York. So this whole canyon is about the same size as the United States across. And not only that, it's also deeper than the Grand Canyon. So the largest canyon we have on Earth, it's much larger than that. The Grand Canyon is only about a mile deep, whereas Valles Marineris is 4 miles deep. So, quite a large geological feature. We think that this was actually created through tectonic plates to create the enormous canyon that we see. And one thing I also want to share about Mars is that it looks quite barren, very dry, a lot of dust. But this world used to be covered in water, and we see a lot of evidence. About 1 billion to 2 billion years ago or so, that's our estimate. Liquid water used to be on the surface of Mars, and we see tons and tons of evidence of this. In fact, if we start to zoom in a certain area, you can start to see riverbeds and river flows, deltas. You can start to see where water used to once flowed across. Oh, there's a perfect one right there. We can see these kind of like stripes right here that are coming across. So this is areas where water once flowed. Scientists believe that Mars used to be covered in 1/3 of water. So the entire northern hemisphere of Mars was covered in an ocean, very salty ocean. But something happened along the history, and now Mars is a barren wasteland as that we know today. But there is still, there's still a lot of focus on Mars because we still believe that there's water here, but in solid frozen water, usually hidden in deep craters or at the poles of Mars's planet. NASA's also found reservoirs of underground water, mostly ice, in different sections of Mars. So as we continue exploring this planet, we're finding more and more interesting things to learn. And maybe one day we humans will travel there as well. Ooh. And it looks like we've just hit the 5 o'clock marker, folks. Wow, 30 minutes has gone by quite rapidly. And unfortunately, we got to explore just a very little bit of our own solar system. I feel like I need a whole hour to explore the entirety of our solar system. But let's make our way back to planet Earth. And we got to take a look at a couple planets and also got to see some objects in our solar system. But as we make our final approach to planet Earth, I just want to remind you all that there's a whole lot that we still need to learn about our solar system and the outer parts of our solar system, like Uranus and Neptune. And as we get better about learning about the planets in our own neighborhood, then we'll be getting better at learning about exoplanets, planets in other solar systems. But so far, we've found more than 4,000 exoplanets in the nearby universe to us, and we haven't found too many like Earth. And this is the only place that we find evidence of life because we humans are here. And not only that, so many different types of species also live here and reside on this planet and call it home. So as we continue exploring more of space, just remember Earth is very special and unique to us, and we should be taking care of it better than we are right now, because traveling to Mars is going to take a it's going to be a very long time to travel there. And if we want to make it anything like Earth, it's going to take a whole lot of work and energy. But we already have a very nice planet here. But with that thought, folks, I do want to end our planetarium show. Again, I want to thank you all for stopping by and watching Tour of the Solar System. If you want to see more space content, this happens every Wednesday at 4:30, and feel free to watch on our Facebook page or our YouTube page. But with that, I will leave you, and I hope you all have a great day. Thank you for stopping by. And once again, my name is Christian. Have a great day, y'all. Bye.